Hello everyone. This is the another class from RT Menu Nagpur Physics Department, and this is the class of computational physics, and our topic is Lagrange's interpolation. So friends, as you know कि uh, interpolation is the very important part in our computation. So first let me discuss what is the interpolation before we come to the point Lagrange's interpolation. So imagine, suppose we have any function as we defined initially, y equals to fx is a function where x is the independent variable and y is the dependent variable. So usually what we do to calculate the y, we need x. But in our case, suppose we don't know the function, we don't have the correct expression of the function, but what we have a table, some data which says corresponding value of x1 and for that corresponding value of y1. It means for the certain value of x1 within the range of x1 to xn, it can satisfy. So whatever the value satisfied by the function is taken. So what we do, what interpolation says, if our function expression is not known, but we know for some value of x function is being satisfied, then we will say the process of this satisfying our function is called the interpolation. But the condition is the value of x must belongs to this range. So this is the part of interpolation. So next we will discuss what are the types of interpolation, and then we will come to the point what is Lagrange's interpolation. So friends, as we were discussing the interpolation, basically interpolation can be divided in basically two very famous methods. There might be the different methods, but we are discussing only this method. But while we are categorizing our method, let me discuss why these two methods are different. So interpolation totally based on the data. Suppose we have the data given, and then as you can see, value of x is here 2, then 2.5, then 3. What we are seeing here, our data is equally spaced. The value of x is equally spaced. In such case, when our x is equally spaced, we always use Newton's interpolation methods. And when something happened like our data is not equally spaced, in that case, Lagrange's interpolation play a very handy role. Okay. So let me discuss what is the Lagrange's interpolation and what are its formula and respective examples what will be taken by my friend Aditi. So So guys, let's here we come to our main topic, Lagrange's interpolation. So what is the Lagrange's interpolation? As I have discussed earlier, suppose we have a data given where these x values are not equally spaced, and corresponding x1 there is a y1, corresponding x2 there is a y2, and all these data are given. So what Lagrange's interpolation formula says, how we derive this formula. First we have to take the second order polynomial which is given by y equals to, suppose a1, a2, these a3, these are constant corresponding to the value. So a1 x minus x1 x minus x3 plus a2 x minus x1 x minus x3 plus a3 and so on. Suppose this is our second order polynomial. When we put the value of x in this polynomial, suppose we are putting the value of x equals to x1 from this table, then this term will get cancelled and similar other term will get cancelled, where whatever the term include x1, and what we get, a1 equals to y1 upon x1 minus x2 x1 minus x3. Similarly, when we put x equals to x2 in our polynomial, we will get a2 equals to y2 upon x2 minus x1. फ्रेम में आ रहा है क्या दीदी? when we put x equals to x2 in our polynomial, we will get a2 equals to y2 upon x2 minus x1, x2 minus x3. Similarly, as we put our value of x equals to x3, we will get a3, x equals to x4, we will get a4, and so on. Next. So, from the value of a1, a2, a3, what we have got earlier, if we put all these a1, a2, a3 and all these constant in our polynomial equation, which was earlier given by y equals to this expression, if we put all this value of constant, then we will get the expression of something like y equals to f of x equals to y1 and the constant whatever the constant value, again y2, similar kind of expression. If we will sum up all this expression in a very neat and clean way in summation form, we will get the final Lagrange's formula, which is finally given by friends as we were discussing. So this was the expression we have got earlier, and if what we are seeing here, these are the y1 multiplying by this term, which consists the this term and this term multiplication divided by continuous multiplication of another term. If we get this form in summation 1, we will get summation of y1. Suppose there must be yn so summation of y term, then multiplicative term, so multiplication of x minus xi divided by xi minus xj. What the thing is here, if there is a x1, then there must not be x1 minus x1 term here. So that's why we are putting this condition here, j equals to I, but j cannot be equals to I in another term. Okay, so this is the Lagrange's finally formula, and we get the another example by Aditi on this formula. Thank you. Please, Aditi.
So let's consider an example of y equals to sin x with given data this. Here we have to find the value of pi by 6. Here we will use formula of y of x equals to 0 plus x naught minus x2 x3 x naught minus x1 upon x2 minus x3 x2 minus x1 into y1 plus x naught minus x1 into x naught minus x2 upon x3 minus x1 x3 minus x2 into y2. Here we have considered 0 since on further multiplication this value will get 0. So after putting the value we will get pi by 6 minus pi by 2 into pi by 6 minus pi by 0 upon pi by 4 minus pi by 2 into pi by 2 minus 0 into 0.07 plus pi by 6 minus 0 into pi by 6 minus pi by 4 upon pi by 2 minus 0 into pi by 2 minus pi by 4 into 1. After doing this multiplication, we will get 8 by 9 into 0.70711 plus 1 by 9